All right, so it's 1:21, so I guess we start, huh? So, nothing special this month for me. I've been busy with things that are kind of all over the place. But here is here's something I thought to talk about h5py. There's been a couple of months I haven't mentioned, revisited what's going on in the h5py lane, and so said why not now? And so let's go with that and see how if there are any questions and things. It's been actually pretty busy. So I'll cover first on the official side of things. There was an h5py 3.8 release recently, and the one of the two major things for this, well, not say major things, but important, relevant things are, first of all, that h5py now officially has wheels or binary packages for Python 3.11, which, if you're not following closely the Python developments, this one was supposed to be the first one that's much faster than the previous Python or CPython implementation. I think this is what first release out of the Microsoft funding on the Python creator and some small team of developers around him to significantly increase the speed of execution of CPython implementation. So this is the one. So there was an interest to have Python 3.11 supported by h5py, and it's been a couple of months, but now with this release, it's all good. The happiness is coming back to the kingdom. And so that's one. The other one is that actually 3.8 is now compatible with HDF5 library 1.14.0. And usually when you have this major release, well, I don't know if it's called officially major release, but whenever the second number in HDF5 version changes, there is a possibility of breaking changes. It's important for h5py to follow this. And so this 3.8 is the first one that actually supports 1.14.0 and future 1.14 releases. And I have to say, that was my contribution out of several that are here. I was relatively productive for this release. And that's good. The next one is a fix about fancy indexing. There are, from time to time, someone tries to do a type of indexing that's natural in NumPy, and it turns out not be supported by h5py, and this is one of those cases that was actually now supported. This one also mine. This is a new property that basically just gives a true or false if an HDF5 dataset is also a dimension scale. And there are communities and there are people like me that think that using dimension scales for coordinate data in HDF5 is kind of good idea. And so I added this test because you could make a dataset a dimension scale in h5py, but you could not check and verify whether or not a dataset is dimension scale. So this is a very simple fix actually. This one is also from another user, which adds ability to when you're requiring dataset, and h5py requiring dataset means that you're looking for a dataset that already exists with some properties, and if it doesn't, it can be created. That now also validates the maximum shape properties of already existing dataset. Again, community contribution, well, all the community contributions, but community means in this case someone who's not h5py maintainer. Adds a meta block size setting when HDF5 file is created. I'm not going to go into what it does and why, but just now it's possible to do that as well from the high level h5py interface. Chunk cache can be configured for individual. Yeah, that's me again. This was something that I came from a project I worked with the US Census Bureau, and it turned out that in h5py, the only way how you could actually say to change how big data a chunk cache can be was per file. In other words, there's a global setting. So all data sets would have exactly the same chunk cache. And that's too broad a setting, especially when your HDF file can have a lot of data sets in it. And so I thought to bring this capability now to individual HDF5 data sets. And now also is possible to set these things when creating one, and also when requiring, which means that you're trying to open already existing data sets. That was the only way how this was possible to achieve in a high-level h5py interface. And these settings are, again, not going to go into them, but they set up the various things regarding data set chunk cache. Why is data set chunk cache important? It is important, especially in two ways. First of all, if you are essentially going to come back to a lot of data that may be in a lot of chunks, then it helps to keep those chunks in memory rather than forcing HDF5 library to constantly read them from the file and then perhaps apply decompression and any other filter operation and then use the data. So for example, any application that has kind of random access, but it would benefit in increasing the chunk cache to the point that you keep sizable amount of chunks constantly in memory. The other option also could be that when you're writing out file, and these chunks are now bigger, and bigger chunks are better for cloud storage or cloud object stores. That's another topic I talked last month about. Then making a couple of megabytes chunks is kind of preferable. But at that point, you are exceeding the default chunk cache size in HDF5 library, which is 1 megabyte. And so to avoid bad performance if writing data, you kind of have to increase chunk cache. Unless you completely supply the data for the entire chunk immediately, and so the library can write the chunk away and never again come back. So that's that. Oh, again me. Oh. So this one and the next one also are just a better customizations of functionality that come from the read-only S3 virtual file driver. It turned out that in order to switch on AWS authentication, you needed to supply all 3 parameters to the ROS3 driver in h5py, and that was the AWS region, where the bucket is, the S3 bucket name, and the credential. And so if none of those or one of those was missing, the ROS3 VFD by the library was not going to actually do authentication, and the requests were failing. So those 2 changes are now just clarifying the situation. So effectively, one is saying that it's activated, or throws an error if not all 3 pieces of information are available. And the other one, actually, this one I scoped it. This one actually allows you to use the more familiar S3 URI when specifying the location of HDF5 file. Before, I mean, not before, ROS3 read-only S3 VFD works only with the URL version of that S3 object. And that's not typically what people use when they're working with S3. They use the specific S3 URI that starts with S3 : / kind of thing. And so in this case, also h5py will do this conversion. Upon seeing S3 URI, it'll convert it to a S3 URL and do the right thing. So again, it's just convenient capability. This one with dataset fields, it's yet another one that tries to speed up transfer of data between HDF5 library memory buffers and the NumPy arrays, or any other Python object that implements the array protocol. And this now basically allows these things to work quicker and better. And finally, and this is essentially one part of support for HDF5 library 1.14.0 is this new HDF5C function to iterate over chunks. It's much faster for a large number of chunks, and has a specifically, it's very important for cases where you need to find out dataset chunk file locations for alternative access to HDF5 data in that file. And I did some benchmarks, I think last week or so, and even for 4 chunks, when using this method, it's about 4 times faster than the previous older methods that were available in the HDF5 library. If you start increasing the number of chunks and you go between, say, 100 and 1,000 chunks per data set, it starts to get to about 40 times faster. And if you really go to a large number of them, say I use the case of 14,000, no, 14, sorry, 16,000 chunks, it gets basically close to 600 times faster. So it's tremendous improvement. And definitely, if anyone can and cares about these things, I highly recommend to use this function and forget about the other, the older method. However, to use this, you actually, it's a slightly different. You have to use it, you have to have a callable Python function, much in the same way that now in h5py you would use a callable if you are visiting all the groups or all the objects in the file. It's exactly the same programming interface, but it's really fast. I mean, even from Python. And that's basically what's in the 3.8 release. If any questions, just stop me and ask, because I cannot see the chat. So if there are any questions or something, let me know. If not, let's go to the current present situation. So right now, a couple of interesting things going on. There was from today, for example, someone had problems with Streamer, and I'm not using Streamer, so I can't tell, but it seems that this is on Windows, and apparently that's not really the happy place for Streamer functionality. But we'll see how this goes. Still very early to tell. This one is kind of reporting a problem from Xarray and H5 NetCDF packages using, and there are problems closing all the open objects in an HDF5 file. But I don't have that problem. I never experienced this problem. And this person claims that all h5py versions everywhere have this error for every processing file. So if you watch the movie, everything, what was this now currently move all the time? It sounds like this. But no, I never experienced this error. So I don't know exactly what's going on here. So we'll see how that plays out. Other than that, there was an interesting case here where you have another package that provides storage in H5 and HDF5 files and use h5py for it, and effectively not actually allowing essentially using floats or integers as keys for whatever data people want to store. And now when that goes to the level of h5py and HDF5 library, then there is an error, because in HDF5 library you cannot essentially use numbers. The keys or the attribute names have to be strings. And so that we see, we said to this person that that's not a problem with h5py, but we'll see how it goes. We have not had any feedback after saying this, so who knows? But definitely, I think this is the final comment here, that h5py could probably throw a more meaningful error in this case. Not something that doesn't really look like, doesn't really explain things, which is float objects has no attributes in code, which is typically Python error. Doesn't really help much people to understand what's going on. Other than that, yeah, there's another idea here essentially to try to sort of bypass HDF5 library when reading or writing chunk data, especially for applications that really depend on multi-threading. or any kind of parallelization that's not based on MPI. And so there is another proposal to have basically, I think here, any kind of buffer, but it's probably going to be a NumPy or something buffer that that can just write into the chunk space. And so we'll see where that goes. But I see a couple of these efforts now popping up here and there. This error, I'm not the MPI user, so can't help this person. All I could ask is the HDF5 library built with parallel HDF5, and apparently it was. So there goes my helpness and my ability to help. But it seems that this person is running a MacBook laptop and trying to run MPI. So we'll see how that goes.
The problem with that specific thing is that under the hood, when we duplicate property lists, if it's built with parallel, it's going to try to duplicate the communicators and stuff like that using MPI com-dupe. So you're going to need to call MPI init before you start doing any HDF5 stuff like that under the hood.
Excellent. You are volunteering to respond to this issue.
I can respond to him.
I mean, yeah, no one else volunteered with this specificity like you, so I guess you are.
Yeah, this isn't a Mac OS problem. I don't think. I think this is just this is how HDF5 works under the hood. Because we want to do the right thing when before, like older versions, we just basically copied it just verbatim. But you're really supposed to use com-dupe when you duplicate a communicator. So we did the right thing, and now his stuff doesn't work.
All right, excellent.
I'll clue in.
Alexander, I was trying to raise my hand. I don't know, it didn't work for me.
I didn't see it. I don't see it.
Yeah, so the first swimmer, he does the right thing. He does Flash, and I doubt that Flash is not working on Windows. My suspicion, he's on NFS NFS file system. That's why it's not working.
Or SMB.
Yeah. So
right. If he's using a Windows share, that won't work. I can go look at that too.
Yeah.
2238.
Right. Mm-hmm.
Add that to my queue.
Yeah, so we'll see what goes. But hey, thanks. On the behalf of the h5py maintainer community, I thank you in advance. So what are the other interesting things? Memory usage of virtual datasets. This one is interesting. This is someone who's using virtual datasets for 680 files. And is reporting quite a large increase in memory. I have not noticed a lot of activity here. Probably because it needs a lot of someone to dive in and see what's going on, and who has time for that. So so I don't know what's going to happen, but I personally was involved in one issue with h5py and virtual datasets that basically kind of turned out to be partly h5py problem, partly HDF5 library. That essentially h5py was very cavalier in how many data space identifiers, I think that was the case for that issue, was generating. And obviously HDF5 library has a certain amount of memory that consumes for every data space identifier, and it was just kept coming, growing and growing and growing and growing. And so maybe this is the case as well of something similar. But I don't know, actually, when I think about it, when you have 680 files, is really virtual dataset the right approach? I mean, it's kind of, yes, I know it exists, but I don't know where are the breaking points of virtual dataset approach in general. But obviously, if you even go through h5py, then things become even more compounded with possibility something goes wrong. Someone was saying something.
I'm just wondering, and Neil is here, if cache for virtual files can be reduced or something, because
yeah, I was gonna say I will have to check. I know there are some circumstances where the VDS will keep every source data set open, and so that you might, among other things, you'll be seeing the chunk cache for each data set and all the other stuff that is held open for the data set. So you could go in and disable the chunk cache for all the data sets, and that'll help. And I think it might be currently, it might only be printf data sets where it doesn't hold every data set open. So I'll have to double check, but that could be something that we could add an option to not hold all the source data sets open in case you're using hundreds of source data sets, which wasn't really something we had considered when we were originally implemented virtual data sets.
All right, thank you. And I think this is pretty much, I think, where there is a one here that I think is an a kind of an older issue and affects a little people who are more leaning towards NetCDF files and NetCDF library and doing things. This been for a long time now. There was a problem, I think, where you actually was trying to override or change the value of already existing attribute, and I didn't really can read this to be, but anyway, I remember this. I actually, when track order is true or something, and then there is this is long-standing issue, and this person who is submitting this is a maintainer H5 NetCDF, which is a Python package that tries to essentially provides the same functionality as NetCDF package and NetCDF C library. So it sort of goes straight from h5py and HDF5 library and creates NetCDF compatible file, NetCDF compatible HDF5 file. And it's kind of stuck here, but I remember seeing this problem and I being receiving end of this error a couple of times, but we'll see where it goes. I think ideally this would be nice to solve on HDF5 library level, but I think that's like minor issue on that, among other problems and work that needs to be done. And that's pretty much, I think, all I can go back down. Oh yeah, this is the one that I kind of am interested in. I do a lot of projects where I have to scoop up information about HDF5 file. And lately, I don't know, lately, let's say last year or maybe two, there is increase in HDF5 files that have a specific compression or compression method used when writing those files. And so the information that's available from h5py interface when you're actually collecting this information is a little too old now. It still operates in the old days when the dplate and szip were the only one available, and for everything else, it kind of doesn't really give you a lot of information. And so there's some discussion here, and I was thinking to come back to this and try to push it a little bit more. I would really like to have something in h5py that gives me a more complete picture of all the filters applied in a specific HDF5 dataset. And what comes here, I mean, what kind of is an underlying issue, or one of the issues is, for example, how to name those filters now. I mean, HDF Group has its web page where you register those filters, but how you name them? What is the identifier that actually you can use that's permanent? For example, that you can say, well, this is this filter, and that's unique. Those kind of things don't exist, or at least are not known to me. And I think this would be something interesting to think about, because it's right now I can read the filter ID, or sorry, that's the identifier that needs to be used. But usually people don't like numbers; they like strings. They're more human friendly. And so if we start using some kind of strings, now what are we talking about now? So there is something I think to think about here, maybe and try to avoid that h5py reports these filters in only h5py specific vocabulary, whatever that is, and try to maybe elevate, because you never know where this information can go. It can definitely go maybe out of a Python world, out of h5py. So maybe we need to spend some time thinking about how to approach this.
Alexander, as I recall, in filter data structure, there is a string that identifies the name. For example, szip will be part of it, and I'm sure there is API for it. I'm trying to find it. If not, it can be created because it's stored as part of filter information. Because there is a data structure that associated with the filter you have to pass when you create the filter. So this information is available.
No, yes. The thing is how you want to use it. So if that string or something is essentially always going to remain unchangeable, in other words, something permanent that we can always use, then we could probably adopt that one, for example, and use it. So when you say to people, these are the filters, you use that string for them to use. That is something. I mean, it's not like, again, it's not going to break the world. I'm just thinking now, because I also had problems whenever I was scooping up all the filters that are applied to a data set, that, okay, something is available in high level h5py, something is not available, and now more and more filters are not available from high level because, again, h5py, that's an h5py issue, not so much HDF library. h5py issue because it, again, need to modernize, to update the way how it reports. And so that's that.
Yeah, get filter by ID. I think this is the function you're looking at that you can use and get it.
So that's your current situation. There was no change on this async IO for h5py that I mentioned whenever last time I was talking about h5py development. There was nothing. So we'll see where this goes. But in very short, where this kind of got stuck is essentially that who is the asynchronous engine, or who manages the asynchronous coroutine. And so this project that basically was interested in this feature has their own some kind of async engine, and it's not really available in the Python world. So that's something that I'll be very interesting to see how these things go. But anyway, there was no change from there. I just want to say there was, I was hoping maybe something will move. This one was deadlock when used concurrently with PyTables. Again, this kind of issues tend to linger for a long period of time because it's normally quite clear who is responsible for fixing. And Python, unfortunately, has this global interpreter lock that seems to always be the culprit for all these issues. So who knows? We'll see how it goes. So anyway, that's the current situation. Let me see. Oh no, sorry. What? What did they do now? Oh, the Zoom is now. Oh, let me see. There is a chat question. Okay, that was Elena. Okay, so how would they erase this or remove this for me? Because I can't see the top tab of my browser. Okay, this was that. Oh, it's gone finally. So I have pull request. Pull request. This one is interesting because this is a new member of h5py community. He's still learning and going through how to add things to h5py, but it's promising, and that's good to see first-time contributor. So we'll see how it goes, but seems to be close to actually doing this. And this is a feature from HDF5 library 1.14.0. So I think this is positive, and that's why I want to highlight that actually h5py still remains fairly approachable for people when they want to add features. That it's not, the bar for contributing is not too high. maybe not for some things, but this is good to see new people being able to contribute to the to h5py code. These are the pull requests. The other ones, I think I kind of mentioned when I'm going through it. Yeah, this one is actually interesting. I don't know what happened with this one, why it's stalled, but this one seemed to have solved a lot of memory problems and segmentation faults when dealing with variable length fields in compound data types. That's very nasty and hairy thing, especially in h5py, because you kind of have to shuffle all those bytes into something that NumPy can recognize. And this person seems to have done a lot of work to clear a lot of problems that used to exist before. But I don't know why it never go forward. So it'd be good to have this in. I also, for example, have experienced from time to time problems with field values and variable length data types and strings and that kind of stuff in h5py, not in the library, HDF library. So it's nice to see that in. Other than that, news is something that's already in, but not in the latest release. So what's available here? Oh yes, this was actually, I think, merged yesterday or today, but very recently. Someone actually exposed the H5Z register filter function now in h5py, which means that now I think what this will enable is that there is another Python package called HDF5 plugin, which provides a number of compression filters that are not available from the HDF5 library by default. So I think they are going to use now this functionality to register those extra filters in a more h5py friendly way. And so that's good. And right now it's available only in the master branch and will be available in the next version, wherever that happens, in 3.8. And that's pretty much everything I have. I have nothing else outside some questions of people, perhaps, or comments over everything I said. No? All right. Then that's pretty much it, I think. Let me see. Did I check? No, check. Good. So if there are no more questions, thank you very much. Someone else is be on the next Tuesday. I'm not sure who, but someone from HDF Group will, and I'll talk to you next month. All right. Take care, everyone.
Thanks, everyone. Bye.